third module, which is about feature selection, and actually our course is starting from here. In section one, in first video, I just talk about why we do this feature selection and deselection, and then we see different methods for that. The main principle for feature selection is actually being to the point. So I want features who tell me explicitly about the answer of my question. This question could be classification, could be regression, whatever. So I have an irrelevant, redundant, or non-informative feature, like the number of noses that we saw in the very first introduction video. Why don't we want it? The answer from machine learning algorithm is that, well, first of all, it wastes my time. I need to compute on that, huh? Second, it makes me complicated. Machine learning algorithm will be complicated. Machine learning model, the model we choose for our problem will be complicated with more features. And third, in some situations, we already know, which means high dimensional situation. We already saw that. In some situation, it doesn't work well. So unnecessary computations happen. Worse interpretability of the model, the machine learning model, and sometimes prediction accuracy is hurt in high dimensional settings. The good, the bad, and the ugly. The good feature is the one who tells me about my question, which is classes, target. A good feature tells me explicitly about my question. The bad feature actually doesn't tell me anything. And the ugly feature is the one who tells me about another one. So a feature who tells me about another feature, or the one who tells me something but not about my question. So there is something in the feature, but it doesn't correlate much with the target. We see them all. X telling me about Y means three things: correlation, causation, or dependence in probabilistic sense. Uh, we cover some definition of all these, and then in next videos we go explicitly into details. The danger zone is that most of the time when you read or you see correlation, the word correlation in literature, it actually means linear correlation, but correlation can be nonlinear. What is correlation? Informal explanation of correlation means that two random variables are correlated if they seem to vary together, if they seem to agree or disagree in some way. Disagree means negative correlation, which is still a correlation. So these two features, x1 and x2, are correlated. They actually vary together. You can put a line which actually explains their change according to each other. Here they actually vary linearly. So do I need both of them to know about the function which is coming out of x1 and x2? This is linear correlation. In this case, if I have x1, then to some extent I have also information about x2 because they are linearly correlated. So I most probably don't need both of them to answer my question, which is about the function which is based on these two variables. Sometimes the correlation is nonlinear. Here, x1 and x2 are correlated to each other in nonlinear way according to quadratic function. This nonlinear correlation is difficult to capture, and we will talk about it